Okay. This is Dylan Hanniford going for the Conway's Game of Life code. So we're starting over here. Apologies again for poor recording quality. Just starting over here in the main Java. Uh, we begin by initializing just the parameters for the community. So this is just setting everything, uh, you know, setting everything up and setting the number of rows that we're going to have in the display, the columns, which should be equal, and they are, the maximum amount of alive cells in general, and the number of mutants. I've found that upping it from 10 helps a little bit in this situation, so I set that to 50. Um, we also had the cap on the number of generations, which plays into this generation counter down here. This connects to the life window over that way, but the generation counter starts at 0, ups it by 1 each time, and caps out at 1,000, which then plays out in milliseconds. Timeout being 100. Next, move over to the cell. So the cell, we have some protected booleans up top, or a protected boolean of alive and a protected integer of age up top. Then we have the two protected cells. This is needed for the derived class, as stated right there. This is setting the alive age to 0, because it'll go up from there. The public static new alive cell and new dead cell, true and false, are going to be important for keeping track of whether or not a cell is alive or dead. Public boolean is alive, return alive, and the public. This one wasn't used. I'm assuming it's going to be used for the color, but I couldn't quite figure out how to get it to change color per generation, which I guess also would have been a little bit confusing because of the amount of generations that we're going to be having. I don't know if you wanted us to do it per chunk of generation or per what the age of the cell was. Probably should have asked that. Uh, but regardless, we have it so that it can return alive cells. And then here we just have the parameters that tell us what is going to make it an alive cell. So if the neighbors are 2 or 3, the cell is going to be defined as alive, else the age is going to be set back to 0 and it will become a dead cell. This sets the color for the cell. Currently it is white, as it should have been. And we've got the big chunk here. A lot of imports. We begin by the array list for the community. We create a private cell community, and then is that right? Yes. Sorry, I thought I messed that up for a second. Cell community, we have the rows and the columns. So right here for the array list, what we're doing is we are building the rows and setting the columns equal to the rows and filling it with dead cells just to begin with. So that way it's an equal amount on each side. This override, I'm not entirely certain what this does, to be honest. That might have been for the previous assignment, but I've been a little bit afraid to remove it. This is just the creation of the cell community randomness, as it states up above. It creates a new random, assigns it to randomly disperse a mixture of live, regular, and mutated cells across this sort of, I guess you could call it a map that we've just made. So again, creates a new cell community. It's going to go over what I just explained, creates a random, and sets it up with a method to randomly disperse it. This right here is what's going to help us get those live mutated and regular cells into that community. We have a public void update. So this is dealing with another generation, creating a list. Here we're going to be counting what's in the rows and the columns. We're going to be adding to rows. We're going to be adding to the columns of the cell. We are pairing neighbors, or we're creating a pair, which is the neighbors, and that's going to be the row of cell and the column of cell generation, add neighbors, and that's going to play in just a little bit further down. Integer row 0 again. I actually had a bit of an error here for a while, and I had no idea what was going on. I had this community get row, all this set to new dead cells, so what it was really doing was just killing off all my mutated cells as soon as they came in. Really glad I caught that. It was driving me crazy for a little bit. Regardless, this is what's going to kind of help control that flow of the new live ones coming in, and it's especially going to be imperative for the sort of takeover of the mutated cells on the list. As integer 2D array, here we're creating a whole nother section. This is going to be implementing some color to the cells and applying it to the rows by kind of going over that list. And here we have counting the neighbors of the cell, as it says in the name. We initialize neighbors and mutated neighbors and first element. This is a lot of the math that you went over. I am still a little confused about this. I missed the part of class where, well, I didn't miss the part of class. I was rushed through the part of class where you were going over this. But I know that this also plays into the rows having the same number of columns. I made sure to make that note. So just by looking at this and trying to decipher what I can, it is just counting up all the information that we've gathered so far. It's looking at whether or not cells are mutated or regular. It's keeping track of it, it's counting the colors, and it's helping with everything in that sense. Final piece of this is the mutated cells. I messed something up. My mutated cells do not die. I'm not sure if that's how it was supposed to be. I don't believe so. I'm pretty sure they're supposed to die after just a few generations, but I was having a little bit of issue with implementing that. They do make live ones though. That's good. Here we have the override, which calls back to the regular cell, overriding what information it had there for the survivability of the cell. And here is the second override for the color of the cell, which will make them red instead of white. Here are just those windows that you provided for us, so I'm not entirely certain what they do. Besides create the window, and here we go, I'm just going to start it up. Hopefully I didn't change anything by accident running through this code, clicking everything. Here we go. We've got the mutated cells starting to take over down there. That looks like that's the dangerous path. And it's just going to run through, eating everything. And I think that's enough. Enough of that. That's it for this code, the run through. I'm going to upload this now, and I will see you later.